Oh, did it again. All right, we are on day 4 of our final exam review. We are doing trigonometry today. So I'm starting on basically the second page, and this all students take calculus. In the unit circle, we can tell in what quadrant certain things are positive or negative. So, for example, in quadrant 1, all of the trig functions are positive: sine, cosine, tangent, cosecant, secant, cotangent. In quadrant 2, only sine and cosecant are positive, which means that cosine and tangent are negative in quadrant 2. And that's the T, sine. All students, sine. Quadrant 3, tangent and cotangent are positive, which means that the rest, sine and cosine and all the others, are negative. In quadrant 4, I have that cosine is positive. Also, secant is positive. That means that sine and tangent are negative in quadrant 4. So that's what this means, this acronym. Cosine 270. How do I find it? Well, I go to 270 on my unit circle. Starting at 0, 90, 180, 270. My ordered pair is 0, -1. And I want to know cosine. Well, remember, cosine is the first number in my parentheses. What's the first number in my parentheses? 0. Cosine 270 degrees is 0. Let me do one that's maybe trickier. Okay, here. Cosecant, -5 pi over 6. So I find 5 pi over 6 in my, there it is. Cosecant. Okay, so cosecant means that I'm going to have 1 divided by sine. So I look and I say, okay, what's sine of 5 pi over 6? The ordered pair is this. Well, sine is this, 1/2. Cosecant is the reciprocal, but it had a negative. The answer is -2. Okay. The other hard one that I think you need is this. Cosine, -17 pi over 3. Okay. Well, the problem is that 17 pi over 3, 1 time all the way around the circle would be 6 pi over 3. 2 times around would be 12 pi over 3. So I'm going to go twice around, 2 times 2 pi. Remember, 2 pi, these two together are 12 pi over 3. Because I need to do 12, and how many more do I need to get to 17? Oh, I need 5 more to get to 17. So then I look at 5 pi over 3, because I went twice around. Oh, I don't want to go backwards, sorry. 1 time around is 2 pi, which is also 6 pi over 3. Twice around makes 12 pi over 3, but I've got to get to 17. So 6, 12, 13, 14, 15, 16, 17, 5 more, and that's here, 5 pi over 3. So this is where 5 pi over 3 is. I look, cosine. Well, the cosine is 1/2. So okay. This was hard because it was more than once rotation around. But like tan pi over 4, that would be y over x, right? rad 2 over 2 divided by rad 2 over 2. Isn't this just the same thing over the same thing? So 1. And then you guys can do the rest. You look at the parentheses and you find it on the unit circle. I'm going to go to 33. Okay, this is just for your reference. This is stuff that I feel like you should know. It's important. So it's there. You can refer to it during a test if you feel you need it, or if you forget what's cosecant, stuff like that.
And
Yep.
for tangent, it's x over y, right?
No, y over x.
Y over x, I got it. Thank you.
Okay. Ready? Find the 6 trig values. Well, that means what's cosine of the angle? What's sine of the angle? What's tangent of the angle? Matching up with, wait, I want to start with sine. Sorry. Okay, ready? Matching up with sine is cosecant. Cosine is secant. Tangent is cotangent. Okay. Now here's the deal. I was told that secant is negative 17 over 8. Well, secant is 1 over cosine. So then, if it's in quadrant 3, I'm literally going to draw a triangle in quadrant 3. The angle theta comes from like the central angle area. And if it's 1 over cosine, and cosine is adjacent over hypotenuse, I'm going to be doing hypotenuse over adjacent, the reciprocal of cosine. Oh, wait, I put it in the wrong spot. That means that my hypotenuse is 17. And you know what? It can't be negative. The 8 has to go with this right here, adjacent. Because I'm going left, and left means negative. So the negative doesn't go with the radius, with the hypotenuse. The negative sign goes with the 8. And then I have to figure out, well, what's missing? What's the missing side? I don't know. Turns out it's 5. But since I'm going down 5 to get to it, left and down, it's a negative 5. So you have to fill in your triangle first. And then, once my triangle has 3 sides, I'm going to go sine, opposite over hypotenuse. But really and truly, I'm hoping that you know that like in your brain quick by now, right? Opposite, negative 5 over hypotenuse, 17. Cosine, adjacent over hypotenuse, negative 8 over 17. Oh, look, it's the reciprocal of secant. Oh, cool. Yeah, we knew that. Tangent, opposite over adjacent. Theta, opposite over adjacent, 5/8. And to fill this in, I got cosecant, reciprocal, negative 17/5, and cotangent, 8/5. Oh, sorry. I'm going to give you little hints on the rest of them. If tangent is negative 3/4, that means that where is tangent negative? And cosecant is less than 0, negative. Where is cosecant negative? So I have two things I need to find out. I need tangent to be negative and I need cosecant to be negative. So, well, tangent is negative in quadrant 4 and in quadrant 2. 4 and 2. Where is cosecant negative? Cosecant is negative in quadrant 3 and quadrant 4. Where are they both negative? Because these rules, this is negative and this is negative. They're both negative in quadrant 4. So I'm going to draw my triangle in quadrant 4 with lots of space because okay, ready? Tangent, opposite over adjacent, opposite over adjacent. Here's my angle. It's always in the center, central angle. Opposite over adjacent. A 3 here and a 4 here. Where's the negative going to go? With the 4 or the 3? Yeah, right. What do you say on Zoom?
With the 3.
With the 3. You're right, because I had to go downward. -3. Hey, 3, 4, 5, triangle. Now when I sit and set up my sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta, everything will be ready to go because I'll just look and be like opposite over adjacent, opposite adjacent over hypotenuse, and you can use these things here. And then reciprocals, A over O, H over O. Am I explaining this clear enough? Like, are you getting it? Trying. Okay, same thing would happen here. You know, cosine is going to be positive, but then cotangent is negative. So you have to figure out where that's going to be. And this one, it tells you, quadrant 3. So I'm literally drawing my boop, boop. Sine, opposite over hypotenuse, opposite over hypotenuse. Okay. All right, I have to keep going, graphing. I'm going to do the cosine for you, the graph of the cosine, and you need to do the sine. And I need to zoom. Uh-oh. Okay, cool. All right, back at the end of chapter 7, we graphed sine, cosine, tangent. And I wanted to remind you of everything. Well, the number in front is my A, the 4 is my B. Now I want to talk to you about the vocab, because I don't even want to graph unless you know what things are. You have to know what everything is. All right, so my amplitude is going to be how high do I go? It's also my A. My A is 1/2. My amplitude is 1/2. My period is going to be like one cycle through. But my period is also denoted by 2 pi over whatever B is. This is the formula you use to find the period. My B is 4. So I'm going to do 2 pi over B over 4, which is going to give me pi over 2. That means that I start not I, sorry, the graph starts repeating at pi over 2. And oh my goodness, pi over 2 is like the end of one period, one cycle. So frequency, when does it start repeating again? It's the reciprocal of my period. To find the value is the reciprocal of the period. So I do the reciprocal of pi over 2. Two over pi. And then my max and min is going to be how high and low, plus or minus 1/2. Okay, how do I even graph this table of values? So, why did I pick these values, first of all? Well, I know that one whole cycle is pi over 2. And then I said, I want to know each quarter. What's half of pi over 2? Oh, pi over 4, right in the middle. Pi over 4. So now I've got the whole cycle, half of it. What's half of that? What's in the middle? What's in the quarter? Oh, pi over 8. What's half of pi over 4? What's pi over 4 cut into 2 parts? Pi over 8, pi over 8. And then again, if each section is pi over 8, then this 3 pi, that's like 1/4, 2/4, 3/4. 1/8, 2/8, 3/8, 4/8. And then I plug in my values. 0, 1, write small, please write small. 1/2, cosine, 4 times 0. 1/2 cosine of 0. Or 0. What's cosine when I'm at 0? 1, 0, C, S. 1, 1/2 times 1. Okay, pi over 8. Anyways, I can do, hey, pi over 8, 4. 1/2 cosine pi over 2. Cosine at pi over 2 is 0. 1/2 times 0, 0. So I'm going through and I'm plugging in my values of x, right? So I'll just tell you the rest because, you know, we don't have forever. Okay. How high did what was my amplitude again? So since it's 1/2, that means that 1/2 is the highest I'm going to go, and cosine is my starting point. Cosine starts down and goes up. Sine starts at 0, 0 and goes up. You need to know this difference. Okay. Pi over 8 is 0. Pi over 4 is negative 1/2. 3 pi over 8 is 0. Pi over 2. Ready? Smooth like butter. That's one cycle. If I put all these curvatures together, I would get a circle. Curve, curve, curve. It would make a full circle if I put it all together. And that's what they call a period cycle. Especially this one. Look at sine. I shifted this bottom curve and I went like, and put it here, it's a circle. Okay. You have to do the sine graph by yourself. The last thing is 252 degrees to radians. In order for me to change from degrees to radians, I multiply by pi over the degrees. How did I know it was that? Oh, because diagonally, I need to have the same unit of measure. I have degrees diagonally. Negative 2 pi over 9 is going to be with the pi at the bottom, because look, diagonally, unit of measure. So the 360 has to go on top. And you just multiply and reduce these fractions. So I just did 36 and 37 for you. Okay, I'm going to stop the recording. I think this was actually a really good day for me to record. And I was all like pumped up and excited too, so that's fun.